Hello, AP students. My name is Nick, and I'm a senior at Allegheny High School. Today, we will be covering soil. Soil is an essential component of Earth systems because it supports plant life, cycles nutrients, filters water, and forms the foundations of ecosystems. In AP Environmental Science, understanding how soil is formed, how it is structured, and how it is classified is crucial for topics ranging from agriculture to biogeochemical cycles. Soil forms very slowly through a process called weathering. Physical weathering breaks rock apart through mechanical forces like wind, water, and temperature changes. Chemical weathering alters minerals chemically through reactions with water and gases, creating new compounds. Biological weathering comes from organisms like plant roots, microbes, and burrowing animals. Over long periods of time, these processes turn rock into a mixture of minerals and organic matter. The rate and type of soil formation depend on the five major soil forming factors: parent material, climate, topography, organisms, and time. Climate is often the most important. Warm, moist climates form soil much faster than cold, dry ones. As soil develops, it separates into layers called soil horizons. Together, these horizons form the soil profile. The topmost layer is our O horizon, which consists mostly of organic matter, which include leaves, decomposed plant matter, and our humus. It is thick in forests, but thin or absent in grasslands and deserts. Now, below our O horizon is going to be our A horizon, which is most commonly referred to as topsoil. This layer contains a mix of minerals and organic matter and is the most biologically active part of the soil. Most plant roots, microorganisms, and soil fauna are found here, making it essential for agriculture. Below that is going to be our E horizon, or our alluviation layer. This is present in mainly older, well-developed soils. This is the zone of leaching, where water removes minerals and nutrients, leaving behind lighter colored material. Under that is going to be our B horizon, or our subsoil, where nutrients, metals, and minerals accumulate after being leached downward. It is denser and richer in materials like clay and iron. Beneath our B is going to be our C horizon, which is partially weathered parent material. This layer contains large pieces of rock and serves as the source for mineral particles above. The lowest layer, or R horizon, is our bedrock. This consists of unweathered solid rock that eventually breaks down to form the layers above. Soil quality depends on physical, chemical, and biological properties. Texture is one of the most important physical characteristics, determined by the proportion of sand, silt, and clay. Sand particles are the largest, giving soil good drainage but low nutrient retention. Silt particles are medium sized and hold water better than silt, while clay particles are the smallest and packed tightly together, giving them high nutrient holding capacity but poor drainage. The combination of these particles influences everything from root penetration to water availability to agricultural sustainability. Soil chemistry also matters. Soils with balanced pH and sufficient organic matter support healthier plant growth. Biological activity, from bacteria to earthworms, helps decompose organic matter, fix nitrogen, and aerate soil. Together, these physical, chemical, and biological components determine how fertile and productive a soil is. To classify soil texture, scientists use soil triangle. Now, you will see this in Miss Stark's class, and you're going to work with it a little bit. This is a tool that shows how different percentages of sand, silt, and clay combine to form specific soil types. By locating the intersection of the three percentage lines, we can determine whether a sample is sandy clay, a silty loam, a clay loam, or any of the multitude of textures. One of the most important soil types in agriculture is loam, which has balanced amounts of sand, silt, and clay. Loam drains well, but still retains nutrients and water, making it ideal for crops. Soils high in clay hold nutrients but can become waterlogged, while soils high in sand dry quickly but lose nutrients easily. Understanding how to read the soil triangle helps predict how soil will behave, how much water it will hold, how easily roots can grow, and what types of crops might succeed in that environment. Now, soils play a major role in environmental science because it connects the geosphere, the biosphere, hydrosphere, and the atmosphere. Plants depend on soil nutrients to grow. Decomposers recycle organic matter, water filters through pores in the soil, and gases are exchanged between soil and air. Human activities from agriculture to deforestation to urban development can degrade soil by causing erosion, nutrient loss, and desertification. Conserving soil through sustainable practices like cover cropping, contour plowing, and reduced tillage is essential for long-term food production and ecosystem sustainability. Understanding how soil is formed, how horizons develop, and how to classify soil using the soil triangle gives us the tools to evaluate soil health and manage natural resources responsibly. All right, that wraps up our AP Environmental Science Soils overview. If you have any questions, use the Google form below so we can address them in the next video. Good luck in your AP Environmental Science class, and I'll see you next time.